Hello there. Good morning to all the evaluators and also to my lecturers. My name is Fong Jun Wei and my matrix number is S51853. So right now I'm presenting the answer for the solid state chemistry video assignment. So let's get to the next section, which is question A. So the two instruments that are to be used to achieve the objective of the research and the reason of choosing these instruments are as below. The first instrument is scanning electron microscope because this technique can provide exactly the surface topography of a certain chemical compounds by scanning a beam of electron on the surface of the chemical compound to produce an image. And the next instrument is X-ray diffraction because this instrument can be used to study the actual structure of the chemical compound to be tested and the time needed to obtain the chemical compound of a certain compound the chemical structure of a certain compound compared to the other instruments is shorter. Next, we'll be talking about the basic principle of the instrument used. And the first instrument that I'll be explaining about is the scanning electron microscope. Alright, the schematics on the upper right corner is the basic schematic of the scanning electron microscope. And the basic principle of SEM is as below. Alright, basically SEM has several components such as the source of electrons, which is the electron gun, a column for the transfers of electron, various lenses and apertures, sample chamber, electron detector, and also a computer for detection of signal. Alright, at first, the electrons will be produced at the source of electron, which is the electron gun right here. And next, the electrons are to be accelerated by the combinations of aperture and lenses to produce a focused beam of electrons. So, the function of the first condenser was to produce a coarse or a basic beam, and the second condenser was to convert the beam into a thinner and readable beams. As for the functions of the aperture was to eliminate the high energy electrons. Next, after the electrons are produced and to be accelerated to here, the final aperture will focus the beam towards the sample that are placed on the sample stage, which is the sample chamber. And next, when the electrons hit the surface of the sample, various components or various signals such as the secondary electrons, backscattered electrons or X-ray will be diffracted from the surface of the sample. And at this time, the electron detector will detect and collect the signals that are transmitted, and it can be transformed into a form that the computer can use the signal to be analyzed. Alright, the second instrument is the X-ray diffraction instrument, and the picture of the instrument are shown as here. Next, we'll be talking about the basic principle of X-ray diffraction. Okay, X-ray can be used to study or identify the specific components or structure of a chemical compound or material to be tested. And the basic principle of XRD was to study the distance between rows of atoms in the crystalline structure so that we can identify the actual structure of the chemical compounds. First, a high energy X-ray will be reflected off the surface of the tested materials, and this X-ray will be reinforced in terms of intensity and the angles and the correct angles so that it satisfies the condition of the Bragg's law. Next, a diffraction pitch that satisfies the conditions of Bragg's law at the beam angles at the correct beam angles will be produced, and this pitch represents one of the spacings in the rows of the atoms of the tested material, which is the D spacing of atoms. Next, the pattern of the D spacing of the tested material represents the basic fingerprints or the identity of the specific chemical compound. And by using these fingerprints, we can identify or characterize each material based on its unique fingerprints. And the final result of SRD will help us to identify the actual structure or the identity of the tested materials. The industry related to the techniques that are used in the research, and the first industry that related to SEM is the cosmetic industry. By using SEM in cosmetic industry, any tiny particles or materials that are being used in manufacturing the cosmetic products can be studied, because by using SEM, any particles that are too big or does not mix well with the other tiny particles can be eliminated by using SEM, because SEM can study the surface topography up to 1000 times, which is sufficiently to eliminate all the particles that are anonymous. And next, if we eliminate the tiny particles that are anonymous, we can ensure the performance and the stability of the cosmetic products, and before it is sold to the consumers. And next, for the SRD techniques, the industry that are related is the geological applications. Okay, SRD can be used in the exploitation of minerals, and geologists can use SRD to characterize the minerals that have been found in the soils or rocks by observing the X-ray diffraction pattern for the minerals. Okay, each type of the crystal or minerals that have been found have its unique X-ray diffraction pattern, and by using XRD, rapid recognition and the identification of the crystal can be done easily, and in the time needed also very short compared to the other analytical method such as TEM or NMR or so on. And also, SRD can be used to analyze the data obtained, and by using this method, we can determine exactly the properties of the composition or the proportion of the composition of the minerals. Okay, and after this, that's all for my presentation. Thank you for all the evaluators for watching my video presentation. And if I made any correction, I made any mistakes in this video presentation, bear with me. Yeah. All right, that's all from me. Thank you.